Hello, this is Jack Jackson. I'll show you a couple little things in GeoGebra here dealing with lattice, polygons, and just dealing with the grid a little bit. Here I have just a basic graphics window open. I'm going to right click here and go to Show Axes and Show Grid and just go to Major Grid Lines. Now I'm going to right click in here also. I'm going to go to Graphics. Over here when it goes to X-axis, I'm going to click on Distance and select 1. Like that, and then do the same for the y-axis. And now I have a grid. I can zoom in and zoom out, but it only shows the integer level grid lines. Okay, then I'm going to go to grid, and when it says point capturing, I'm going to go snap to grid. Now what this is going to allow me to do is basically do what you do with a geo board. You can have points on here that are going to snap to the grid. So if you get anywhere close to where the grid lines cross, that's where the point is going to snap to. So if I move this, I can force points in between, but if I get close, it'll snap it to the grid line there. If you notice the coordinates there have integer values. So those are called lattice points, where the grid line crosses. Okay. By the way, let's see where I am here. Looking at the grid line here. We've got major grid lines. Basic here, I can click on the color of the grid line here. Okay. And you can click on a basic different colors here. A gray is a really nice if you're looking on the screen. If you're going to print it out on a piece of paper, then maybe a black grid line might be a useful thing. Okay, so that's for the axes, and then for the grid here, we can do the same thing. So the grid is a like I say right now it's a gray. I can switch to a black if I'd like to see the black. So I think the gray actually shows up better. One of these darker grays shows up better on the screen, but a black might show up better on a printout, like if you're making this out for a test or something. Okay, so anyway, here we have a grid line. Now we can use the polygon tool here and then snap to some points here, and this makes a lattice triangle. I can click on this and show, let's see, go to settings, and if I go to basic and show the label but choose the value, it's going to show the area of that polygon. And if I click on the sides like this and go with value, it's going to show their lengths. Of course, those lengths are rounded off. Some of those are irrational numbers. You can use the Pythagorean theorem, for example, to find this side here. Turns out to be 1, 2, 3, 4 square root of 2's here, and so forth. You can find those sides exactly, and then here they are approximately. And there's the exact value actually for the area. And a couple of interesting things happen about lattice polygons is you may notice that their areas are always either whole numbers or a whole number plus a half. And there's some interesting results that you can see with that. So I'm going to let you explore that and see if you can come up with a formula for different areas of lattice polygons based on just the interesting thing to look at is the number of points on the boundary. This one has 1, 2, 3 points on the ends, but also has another 1, 2, 3 here on the boundary, no others. Whereas we put one, say, going like this, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lattice points on the boundary. And it has some in the interior, 1, 2, 3 lattice points on the interior. And you might look at other ones here. And so see if you can explore with that particular thing, and you might find out a really interesting result. But this shows you something about how we can make some lattice polygons. So these are kinds of things that you can make on a geoboard, for example. So these points where these grid lines cross are basically like the pegs on a geoboard. So we can say, okay, well, what kind of quadrilaterals can we make? Okay, that point's not quite on a lattice point. If I get a little bit closer, it'll snap to it. And so there's a quadrilateral. There's a right trapezoid, for example. Or can we make a rectangle or a square? There's a square. How about a rectangle? Okay. Can we make a right triangle? Certainly make a right triangle if we use vertical sides, horizontal sides. But can you make a right triangle? There's a right triangle that's an isosceles right triangle, but the perpendicular sides are not vertical and horizontal. Okay, so you can experiment with that a little bit. Here, what other kinds of things can we make? You know, there's a rectangle with a right angle, but only just one. Here's can we make a parallelogram, for example? Let's see if we can make a parallelogram here. Okay, there's a parallelogram, not a rhombus, but a parallelogram. Here's a rectangle. How about another parallelogram here? There's another one. There's an isosceles trapezoid. There's another trapezoid. Here's another trapezoid there. Let's see. Here's one where here's a trapezoid where we have both have negative slopes there. And there's all kinds of other different things you can have, and you can make. You know, how about make a pentagon? Okay, so let's see. There's again, if I just get close to the corners there, the lattice points, those things will snap in place and make a lattice polygon there. So there's some examples of how we can look at some lattice polygons.